One number for many. Which number speaks best? Watch and decide.
Welcome to the moonlit data marsh. It's a quiet wetland, but if you look closely, you'll see a landscape mapped by numbers. Watch as she settles in. She knows there is plenty to observe here. The math is built right into the environment. Every stone, shell, and reed holds a piece of a larger pattern. When we collect data, the raw measurements often look chaotic. A scattered pile of numbers is hard to read, so we look for a measure of center, a single, simple value that summarizes the entire group. But before we start applying abstract mathematical terms, we have to watch the scene. The quantities exist out in the wild first. Take this great blue heron, stalking slowly through its territory. Each reed it passes represents a specific data point. Look at the tags naturally resting on these reeds. We have our raw values, 6, 7, 7, 8, and 12. If we line them up by size, the middle value is 7. That median is our measure of center. It gives us a typical height for this cluster of reeds. Curious. But if I tell you the typical reed is 7 units tall, do you actually know what this patch of the marsh looks like? Does that single number tell the whole story? To find out, we have to look at the extremes. If we take the highest value, 12, and subtract the lowest, 6, we get a spread of exactly 6 units. This is the range. This dot plot shows the dataset clearly. The median sits right at 7, but you can see how the total group stretches outward to those highlighted endpoints. So, while the typical value is about 7, a true picture of this environment requires knowing that the data varies from 6 to 12.
Center finds the middle. Spread shows the scatter. Both matter here.
Moving further into the quiet marsh, the heron begins surveying a completely new collection of interesting items in the shallow water. Here we find 2 sets of shells. The first set reads 4, 5, 5, 6, 6. The second set is almost a perfect match, 4, 5, 5, 6, and then 20. In the first group, the average, the mean, stays tightly anchored near the main cluster, around 5. All the shells are similar in size, keeping the center stable. But look at that final shell in the second group. A value of 20 is significantly larger than anything else around it. These dot plots map both sets on the exact same scale. Watch the second plot. That single massive value pulls the mean upward, away from the cluster. By dragging the center higher, it stretches the overall spread, making the entire set highly variable. A measure of center can easily be manipulated by one extreme outlier, masking what the data actually looks like. A single number cannot be fully trusted without context. As the heron continues wading, its path intersects with carvings along the muddy bank, recording 2 different groups of data. We have dataset A, 8, 9, 10, 11, 12, and right next to it, dataset B, 2, 6, 10, 14, 18. If you isolate the middle number in both lists, they both share an identical median of 10. They have the exact same center. Contrasting these dot plots reveals the illusion. Set A is a tight cluster. Set B is scattered wide. Let's check the math. Set A ranges from 8 to 12, a range of exactly 4. Set B is 2 to 18, a range of 16. If you only checked the center, you would assume these environments were identical. Measuring the variability is the mandatory second half of the picture. As the heron finally leaves the shallows, the patterns it leaves behind are clear. Summarizing data requires you to track 2 things at once. You find the typical value to anchor your understanding, and you measure the spread to know how much the rest of the group varies. The math doesn't invent these relationships. The environment shows us how the numbers behave, and the notation just records what is already true. And as the next arrival steps into the water, a new set of data points begins to form. Look closely at the scene around her. Which mark in the environment definitively proves the mathematical relationship? And how does the animal's natural action make it true?
Center is not enough. Spread completes the picture. Measure both next time.